notice when you run it, nothing is showing up. If you look in your sprite area, you see that they have added 3 sprites, but they have not been, those objects have not been added to the window yet. How are you going to add them to the window? No, not cheating. Not cheating. Adnan, who's missing over next to you? Isn't there somebody sitting to your left? No one, no one anymore? Okay. 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 So, real quick, for your warm up, under scene creation, the 3 lines you were adding all were window.addObject. You just make the argument different based on your 3 different instances. Window.addObject, and then your 3 instance names. Okay? We're going to go into precise positioning now. So go ahead and open that up. Okay. So, so far we have learned to use our XY coordinates when positioning objects on a window. However, you have other methods as well. And it's important, I think it was Adnan who reminded us of the term I was looking for, your origin point of objects. They're not always the same depending on what they are. So we're going to see that here and learn how to position them a little bit better. So when we say precise positioning, we're simply referring to setting the position of a graphic by choosing the correct attributes to use. So we've used the X attribute for horizontal, the Y attribute for vertical positioning, and the TS app library provides us with other attributes to use with windows, sprites, and text. So if we look here at this graphic up on the screen, the one thing that I want to make sure that I point out is that whenever you have a graphic, no matter what size or shape the graphic is, there's always a rectangle around it, a bounding box, rectangular bounding box around it. And if you look here, notice that the XY, the origin point of this graphic is the top left. Is that the same place it was that we discussed yesterday with the text? Y'all remember where we said the origin point of the text was? Bottom left. Bottom left. Okay, so it's different. Notice now that you also have a wizard.center X and a wizard.center Y. And that becomes very helpful, okay? So we can set them for sprites, but not for the window because we can't move the window around. The X and Y attributes point to the top left corner, while the center X and center Y attributes are the very middle of the window or the sprite. Note that for sprites, you should imagine an invisible rectangle around the image when thinking about the corners and the center. When we look at text, or a text label rather, instances are a little bit different, okay? So in addition to X and center X, we can also use a right X attribute for text. When would center X and right X be useful for positioning text? Remember yesterday, how did we use right and center? Yeah. When we want it center aligned in the text box or right aligned. Now note for the text, the Y attribute is the imaginary line that the first row of text sits on. So right here, see how this one is 2 lines? So it's not at the bottom of the second line, it's at the baseline of the first line. Baseline. The baseline is, if you're writing on a piece of lined paper and you're practicing your handwriting back in whatever grade you do that in, and you have to make sure that your letters line up on the line, except for the descenders like the Y or the P or something like that. They all line up on the line. That line is your baseline, and that is where they measure the Y origin point. And the reason for that is, instead of doing it at the top, we have so many different sizes that the top could be, that there's no way that it would be the same on each one. But if we say baseline, that's going to keep it consistent no matter what font or letters you use, okay? All right, let's go ahead and switch to the code view. And let me hide some things to make this easier for you to see. Okay, so if we run this right now, we have a window, we have a whiteboard, and we have the letters no homework, or the text no homework, which will be true if you finish everything in class, okay? But it would look better if everything was centered in the window. And right now it's not. It's all lined up at the left. So what we want to do is after running the program, we know we want it centered. So we have to add some code. So here we have a line whiteboard and text. And we are going to add 2 lines of code here. Board.centerX equals window.centerX. And then repeat that with Y. Okay? Now, if you run this program, what changed with just these 2 lines of code? Nothing. The board moved. The board is now centered on the window, but the text still is not. Okay? So now, after those 2 lines, we want to add 2 more that is going to center some text. So I am going to put in text align equals center. That way it is centered in the text box. And if you look up on line 12, notice that yesterday I said that the width of that window is 1018. Well, here it just said board.width. So regardless of what it is, they're putting in a dot width, so it's taking on the width of it, okay? So it's automatically going to be, that text label is going to be centered there. And then if you do text.centerx equals board.centerx, now it is going to apply it to the board, the text label to the board. Okay, and now when we run the code, it is centered horizontally. It is not centered vertically. Okay, so now we have to add something different. We can't get the vertical center of the text, but we can still use text.y to get it pretty close to the vertical center of the whiteboard. So we are going to add text.y equals board.centerY. Then run it. Why? So run it and see what happens. Okay, yeah, so we can't get the vertical center of text. So we can't, there isn't a way for us to do text.centered y. So it's just text.y equals board.center y. Yes. Okay. Did everybody get theirs to work now? Go ahead and hit your, hit submit, except for hang on, because I forgot one slide. Okay, so these are your attributes that you used here. Sometimes it's going to take a little bit of trial and error to get things positioned where you want, but you need to realize that there are different methods for getting it there. Obviously, you have the absolute of positioning XY coordinates, but you also have the ability to center things horizontally and vertically as well, okay? All right, now we have draw order. Go ahead and open that one up. Okay, so as we add more graphics, we need to think about what happens as they start to overlap. And that brings us to draw order. So those of you who have ever used a graphics program like Photoshop, you know that you had layers where you were able to reorder things, and whatever was on the top was what of your layers was what was visible. And usually whatever you drew first was at the bottom layer and therefore in the back, okay? Well, similarly here, in that if it was drawn first, it's going to be in the back, but there's a way for you to reorder it. So think of the draw order like painting on a canvas. The first thing you paint goes directly on the canvas. The next layer of paint you add covers it up some, and so forth and so on. So if you look here, we've got two sprites, a pig and a cow. They've been added. The pig was added first, so therefore it's behind the cow. Okay? So you see that it was added first because we typed from top to bottom, then the cow. All right, so if we create these two, like I said, pig is at the back. We want to be able to control the draw order of sprites and text even after they are added to the window, and the TSApp library allows us to do that. Ideally, we will set the draw order we want when we add them to the window, but we can use these functions to learn in a moment, mostly to change the draw order while the program is running. So let's go ahead and open the code and go ahead and run your program. And if you run your program and let it sit there, you're going to see that you just have a stage and you have a door sitting there in the middle of the stage. And nothing else happens, right? Okay. So, if you look at starting at line 9, this is where it's defining the different sprites: the window, the background, a closed door, an open door, and a Yeti. Starting at line 17 is where you're adding those objects to the window. So as you can see, which object is added first? The door open. And then that means that door closed was added last, which is why it's in front. Okay? So what we want to do is we need to go find this open door. And actually, let me show you real quick. When you look at main loop, you have a variable here called iteration. Remind me what iteration is? Yeah, you iterate one time. So if you are using iteration, you're using repetition. It's going to repeat itself, okay? So it's starting off at 0, and it's saying while window is running, you are going to increment iteration by 1. So here we go on line 36. We've got open door, and we are going to use an if statement. And we are going to say if iteration equals 100, then window dot move to back, the door closed is going to move to back, and the door open is going to move forward right here. Now, the move to front and move to back methods will move a sprite all the way to the very front or the very back, while the move forward and move backward methods move a sprite only one layer at a time. So we remember that the door open was all the way in the back, even behind the background. So what it's saying is, and I'm not sure, I didn't run it after this one. If we let it get to 100 in the iteration, our door open is still behind the Yeti. So it only moved forward, so that it's in front of the background now. Okay? And then you can't see the closed door because it's all the way in the back. Now, you do have options to set things to set visibility on objects. And you could set it using false as the value to hide the closed door. But in this case, we're just going to move it to the background and bring the other one forward. Now, after the move Yeti comment, we are going to have the Yeti scale a little bit, meaning get bigger, once the iteration reaches 150. So if iteration equals 150, Yeti.scale is going to increment by 0.1. Now, I do want you to see that when it says iteration equals 150, it's meaning when it equals 150. It's not going to continue to scale and increment by 0.1. It's going to increment by 0.1 one time when iteration hits 150. Okay. All right. So if we play it now and we run it, and we wait for the 100th iteration, the door opens, and then on the 150th, the Yeti steps through. Well, I shouldn't say he steps through. He actually was already through it. It's just that he grew bigger, so it became more evident that he stepped through. The last thing we're going to do is we're going to close our door again. So there, after the comment on 48, you are going to say if the iteration gets to 200 or equals 200, you are going to move forward the door closed and move to back the door open. And then go ahead and run it and see what happens. Okay, so it finishes with the Yeti in front of the closed door. Okay? Everybody get that? Okay. Let me go back to the slides. All right, so here are the methods, because they did something that we used here to move sprites forward or backwards in the draw order, okay? We had move forward, move to front, move backward, move to back. And I want to make sure everybody understands the difference between move forward and move to front. They could do the same thing in moving something to the front of the draw order, depending on where they were originally in the draw order and how many objects you had in the draw order. But let's say you had 10 objects and it was at the back. Move forward is only moving it forward one step in the layer, in the draw order process. Whereas move to front is going to bring it all the way to the front, okay? So make sure that you understand that. Go ahead and hit submit. And you have 4 practices on precise positioning and draw order. You should be able to finish at least the first 2 during class, if not all 4. If you don't finish all 4, you do need to finish them for homework, okay? But like I said, I do think that you can finish all of them. Let me know if you have questions or need help on them. And know that you can talk things out if you get stuck. And remember that tomorrow we do have a lesson check, and Friday a Unit 3 exam. Okay?